Alright, this is AP Calculus. We're on worksheet 10-2. This is the key. We had a late period, so I'm not going to get through all of this video, I think. Okay, so we have a graph of f that's happening up here. We have to pay attention to the label here because sometimes it'll mess us up. I don't think I try to trick any of us in this homework, though. Alright, so the main things I'm looking for, I guess a lot of things. All of this stuff, you have to have the definitions memorized. Since all of these are g, I need to take the derivative of g and the second derivative of g. So I'm asking myself, what is g prime? That'll help me answer CV's increasing, decreasing, relative of extrema, etc., etc. So what is g prime of x? Well, I need to take the derivative. We saw how to use the second fundamental theorem of calculus. You basically plug this in and take the derivative of it. I'm always going to make it nice and easy for this worksheet because it's an AB worksheet. I can eventually change that in the future. So this is just f of x. Done. So if I'm talking about g prime, I'm really talking about f of x, and on a graph of f of x on a graph of f of x is height. So I'm going to come over here and write the notes. This is height. And I'll do this in advance. I don't need it quite yet, but what is g double prime of x? Because I'm going to need the second derivative test for where it's concave up and inflection points, etc. So I need to take the derivative of that function again. The derivative of f is f prime of x. So if I'm talking about f prime of x on a graph of f of x, that's the slope. I love it when you guys fill in the blank right before I do. It means that you're paying attention, you know what's going on. Yeah, so let's talk about CV. So CV, the definition is where f prime, this height, is 0 or does not exist. So where do I have a height of 0 or a height that does not exist? So I have a height of 0. Let's see, is this including? So it looks like I'm including this 0 here. So it has a height of 0 there, there, and there. So my CVs are at 0, 4, and 6. So I'll say at x is equal to 0, 4, and 6. Okay, where is it increasing? Where do I have a positive height? Where is it above the x-axis? Well, between 0 and 4, not including 0 and 4. So I'm going to use these parentheses, between 0 and 4, and nowhere else. Okay, so you can also do this a different way. You could say 0 is less than x. Ooh, that's a bad x. X is less than 4. So there's two ways of saying that. I'm sure that you guys are probably more comfortable with interval notation instead of inequality notation. Where is it decreasing? Where am I below the x-axis? Between 4 and 6, because that's below the x-axis. So between 4 and 6. So you write it like this, and practice writing it the other way just in case. They'll never force you to, but I mean, it's nice to know, especially if you go to college class and they say use inequality notation. 4 is between x, which is between 6. Okay, relative extremum, that's where I cross the x-axis. That's where I have a height change. A height change through the x-axis, that only happens at 4. So that only happens at x is equal to 4. And where do I have a relative minimum? That's when I have I go through the x-axis from the negative to the positive side. From the negative to the positive side, that's a positive to a negative. That's clearly positive there, negative down there. So that's not a minimum, that's a maximum. So we can say x equals 4 is a maximum. There's no minimum, so we can say none. Or D and E, whatever you want to say.
If the 6 were to continue, then would that be a...
Yes, exactly. Yeah. If this continued up right here, that's a negative to a positive. And the cool thing too is all of the relative extremas, as long as they're listed correctly, those are the ones that you have to choose from. So make sure that you're hitting all of your relative extremas between these minimum and maximums, right? Where is it concave up? Okay, so concave up is the second derivative test. Concave up is over here. So I'm talking now about the slope. Where is the slope up? Where's the slope positive? So I'm thinking the slope is positive there. Slope turns into a negative down here. So slope is only positive between 0 and 2, and somewhere else also. So I'll say between 0 and 2, and then you have to do this little or symbol, and somewhere else as well. So where do I have positive slope? Still negative slope, negative, negative, negative. Hey, right here I have positive, 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 positive. So between 5 and 6. Again, that line isn't actually there. So between 5 and 6. 5, 6. And then you can do that with inequality notation. It's between, so 0 is less than x less than 2, or 5 is less than x is less than 6. All right, that's concave up. Concave down, again, talking about slopes still. Where do I have a slope that is down a negative slope? Well, it starts right here, negative slope, negative slope, negative slope, and it ends all the way down here at 5. So just between 2 and 5. Not including 2 and 5, because at 2 I have a slope of 0. At 5 I have a slope of 0, not negative. So between 2 and 5. 2 comma 5, and the other way of saying that is 2 is less than x is less than 5. Inflection points, again, still talking about second derivative test. This is where I have a sign change in our slope. So where do I have a positive slope and then a negative slope, or vice versa? Well, I have a sign change here and here in terms of the slopes, because I had a positive slope, then a negative slope, then a positive slope. So yeah, 2 and 5. So we'll say x is equal to 2 and 5. There it is, and that's all I have time for in this video.